Hello and good morning to you all. I am Path Oru, event planner for Microsoft Reactor Bangalore. Thank you all for joining us today at Reactor. The session will run over next 3 hours, including Q&A. The session will be recorded and we uploaded to our Reactor YouTube channel. We will share the link of our YouTube channel in the chat section soon. Before we begin, please have a look at our code of conduct. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so be respectful of other people views, understand of differences, be kind and considerate in a way you engage. The chat will be open throughout and we will encourage you all to participate. Also keep your mics muted during the session. I would like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker and co-founder at TechScalable. Being passionate about ever evolving technology, he works on Azure, GCP, machine learning and blockchain. He is also a certified Microsoft trainer. Over to you, Shivam.
Thank you, Parth. I'll share my screen. Okay, so welcome everyone. Hopefully all of you are doing well, and a very good morning to all of you as well. Now, let me walk you through the agenda for the day, and then we'll get started with the designing and the demo and so on and so forth. So whenever you have any questions, you can put your questions in the chat window. The chat is open with me on my secondary screen. I will take your questions on the way, and rest of the questions we'll take on in the during the end of the session. And right, so if I just walk you through the session over here, we are going to understand how WordPress works with Kubernetes and what is the meaning of MySQL flexible server. So this is a new type of it's one of the deployment modes of MySQL in Azure as a platform service. So we will understand how do they work together, how do they interact and engage together. So we will be going through the basics of AKS as well. So this session is for someone who this session is not depending on any previous session. If you have been joining me for last 25 sessions as such, some of the sessions are depending on any previous session and so on and so forth. This is totally independent as such. So we'll talk about the fundamentals of Kubernetes as well. We'll talk about the fundamentals of MySQL as well. We will build the WordPress Docker image. We'll talk about the Dockerfile. We'll see the Kubernetes manifest file. We'll see the various elements which are there. How does it look and feel like? What's the details over there? And we will deploy the WordPress to AKS, and we will see what else can be done. Can we have how can we make it scalable? What are the various things by which you make it secure? Right? Security, scalability, SSL certificate, and so on and so forth. So we'll talk about all these things. Now, after the session, whatever we will be doing today is also available as a, you can say, like a learning module as well. So I'll put those learning module links in the chat window. You can bookmark these links, and whatever we cover will also be there in a more structured manner, right? We may be jumping back and forth between the demos and the whiteboarding and so on and so forth. So if you want to, sorry, if you want to reproduce everything, you can do that from those links as well. Now, if I give you a if I just take you back to my whiteboard, I have a couple of things over here. I'll walk you through this. We'll start from scratch as well. Uh, I just want to, you can say, so if I just uh, explain how we are going to take this session forward, we will just take the elements, the fundamentals first, right? Let's go through the fundamentals of AKS. Let's go through the fundamentals of AKS is Azure Kubernetes Services. So let's go through the fundamentals of Azure Kubernetes Services, and let's go through the fundamentals of Azure SQL database for Azure database for MySQL flexible server. Let's see what is that flexible server means. What is the meaning of that? Because you may be aware of the platform, the PaaS solutions which we have in Azure. So how is this different from the PaaS solutions, right? Or why is it called as flexible server? So we will see those things, and then we will start from we'll go into the demonstration, and we will go through that, right? So I just want to zoom in here and just want to walk you through a couple of fundamentals of Kubernetes. So even for those who are joining us for the first time, maybe just for this session itself, will not be left behind, right? Okay, so let me find my uh, graphic pen over here. Okay, check this out. So now, if you are aware of, if you have heard about Kubernetes, I hope you have done it before. Basically, it's one of the go-to container orchestration solution as such. And in Azure, it is called as Azure Kubernetes Services, where the Azure flavor of Kubernetes, or not really a flavor of Kubernetes, is the open source Kubernetes, but some extra things have been added to make it more, you can say, more, you can say it's far more integrated with Azure, like they have their own container networking interfaces and so on and so forth. So if I just get started from somewhere, let's put some numbers over here. So imagine you're working with the Kubernetes cluster for the first time. This is where you are right now. You're over here. You just want to understand what are the basics of Kubernetes and so on and so forth. So let's say this is where you are, right? Now you want to, what you did, you want to get started. So the very first thing is we have to create a cluster. We will be doing it very soon, right? When we create the cluster, it will be having like a master and a worker architecture. So this is the master over here. And for example, in my screen, I have these two workers over here. So this is one worker, and I'll create one more worker over there like that. Now in Azure, when we deploy the Kubernetes cluster, the master is taken care by them. They take care of the master as such. So it's, we don't even pay for it. Like the master is the high availability of the master node, the cost of the master node is taken care by the cloud itself. So in Azure that happens, right? So this is one of the, you can say master is very important. If you want to, I can say, uh, if you create a Kubernetes cluster on premises, taking care of the master, high availability of the master, making sure the state management of the master or the HCD of the master is kept very high available, that becomes a problem. But when we go to the cloud, like in Azure Kubernetes Services, that master is taken care for the customer. Okay, now, anyways, if we zoom inside, see there are a couple of elements here. Let's see this. So what will happen in the master node? We will have API server. Let me use a different color over here. Maybe I'll just put some dots over there. It seems I numbered everything. So we have these elements over here. API server is there, one of the element in Kubernetes master. Another element will be the controller managers. Now controller manager is there are so many controller managers, like different type of controller managers. These are the control loops. They are the ones which are doing, you can say, maximum heavy lifting in Kubernetes. They are the ones by which the functionalities and the various type of things are provided to the end customer. You can even have like we have things called as operators. Operators are like custom controllers which you create or you get it from some third party. So even those are possible. So we have API server, controller manager is there. These are control loops which will be doing things for us, right? Now the database is over here. It's called as HCD. HCD is based on there is a database called as Bolt. It's based on that Bolt database. It's basically I have created it over here. It's a key value pair, and this is the database over here. Apart from this, we also have another very, you can say one of the major components in the Kubernetes cluster master will be scheduler over there. So scheduler will be doing schedule related things as such. So if I just put these points, we have these four components in the master. And apart from that, if we just go and have a look at the workers, we have a couple of things in the workers. There is one you can say one agent over here called as kubelet, which is at the worker level over here. These are used for the management of the resources and the entire the communication between the master and the workers as such. Now apart from that, different container runtimes are supported, and so I have them over here somewhere, it seems. So different container runtimes will be somewhere over here. So let's say Docker, RKT, uh, container D, and so on and so forth. So these are like all the possible container runtimes in open source Kubernetes as such, not specifically not specific to any service. So these are the basic elements. Like there is a worker master architecture, and we have the various services in the head and the worker nodes. Now what happens is we will have a look at the flow as well. Step one, step two, step three. When you deploy something, then what happens, right? We'll just put some numbers on it, or we'll just recap the numbers which are there, right? So let's say you want to run, hypothetically imagine, let's say we already know how to run Kubernetes, sorry, WordPress over there. So you open your laptop, deploy the WordPress instance inside AKS. Just hypothetically, put some numbers here to understand how the flow works. So you basically open your laptop, you install one, you can say client over there, kubectl, and with this client, you simply let's say you did the submit, or you applied the file. Now, so the communication happens to the API server. API server, it exposes the APIs internally, externally to Kubernetes. So API server receives that particular post operation, and then it writes into etcd. So over here it goes to, and it says, okay, we'll put that in the etcd. So in etcd, it will have some entry will get created over there, but nothing apart from that, nothing will happen as such. Now we have various type of controllers. These controllers will kick in as such, right? Now what these controllers will do, these controllers from that initial deployment will create some you can say pods like that. It, and nothing will get created actually. It will just be like one, you can say, status change will happen, or one entry will get created. That pod is pending over there. Now once this pod is pending, all the elements are listing to all the different elements. There are bindings as such. What this scheduler does, this scheduler basically kicks in as soon as the pod is in the pending status over there. The scheduler will get kicked in. Scheduler will basically uh, what it does, it only just tells which pod will run where. It doesn't do anything apart from that. So scheduler, it does the binding of the pods to the nodes. What are these pods? I'm using this word pods. You see this dotted line over here. Whenever you deploy anything in Kubernetes, it is running inside the pod, like the containers which you have, the Docker container which you have over there. Those are running in these pods over here. These ones, right? So these dotted lines, these are the, you can say, every technology is having some sort of like smallest level at which we can work with the technology. Like hypervisors are the, you can say, virtual machines are the most atomic things in virtualization in hypervisors as such, which is like operational, which can be operational. We're not talking about any elements like vnic and so on and so forth. So similarly in containerization, containers are the atomic things. Here we have the pods, the in Kubernetes inside pods, the containers are there. So what the scheduler does, whenever you do the deployment, right? You are saying, okay, run 3 instances of the WordPress, or 5 instances of the WordPress front end, run 10 instances, right? So these 10 instances are running in the pods over there. So 10 pods are there for those 10 instances. Now, so the purpose of scheduler is, scheduler will schedule which will run where, like which pod goes where. If you have 10, then 5 here, 5 there. Like if you have two nodes, or if you have more nodes, and so on and so forth. So what this scheduler does, it basically, we can say, it assigns the pod to the node. So if I just show you what it does, if I just go back to the left hand side, you see this. From the step number 7 to step number 8, the pod has assigned the node. One will go in node 1, pod 2 will go in node 1, pod 3 will go in node 3, sorry, node 2 over there. So it will assign the pods, like, okay, you go there, you go there, you go there. How it does it, right? If I just explain the little fundamentals behind that. So what it does is, it basically is having a type of see, check over here. So what it does, the scheduler, it basically uh, yeah, there are two concepts over there: predicates and priorities. Like predicates are the hard limits, and the priorities are the soft limits. So the predicates are the, like, let's say, like some sort of limits are there. Maybe it sort of does a short listing of the available worker nodes where the pods can be, you can say, assigned, or where the pods hypothetically can run later on. So what it does, when it does that filtering operation, it does the filtering operation by these hard limits and the soft limits. Like hard limits are like some sort of system limitation. Maybe memory limitation is there. Maybe node doesn't have resources, right? The priorities are the soft limitations, which if followed, great. If not followed, then also it will still run. So these can be, you can say, violated. But based on that, what it does is it filter out. So all the nodes which are there, it put the filter based on the predicate. So like the hard limit. So out of 10 nodes, let's say 2 got selected, and then, or let's say 3 got selected. Then based on the priority, it will sort them out in the we can say a descending order, and we'll pick up the top 2 or top 3 or whatever, wherever we need to schedule things. So that particular job is done by this component called as scheduler over there. And this scheduler will go, see, at step number 8, the pods were assigned. See over here, pod 1 will go here, pod 1 will go here, pod sorry, 1 2 3. I should just put numbers there. This is we are assuming we are running 3 instances. So 1 2 3 like this. So let's say pod 1 goes to node 1, pod 2 goes to node 1, pod 3 goes to node 2. In our diagram, only 2 nodes are there. So nodes are these worker nodes, right? Which we have created in the bottom of the page. So let me just, yeah, over here, this is the nodes. And the other one is the other node over there. This is node 1, node 2 for us. This is the other node, the worker. Okay, so if you see the point number 8, which we have mentioned there, like what happens, the scheduler will schedule it. Okay, you go there, and so on and so forth. Now after that, what will happen is the kubelets, you see these kubelets over here, they will get the information from the API server. So now they are supposed to start doing it. So what these kubelets will do, the kubelet will do over here. In my diagram only we have 3 pods. Yeah, so we have done it correctly, like 1 2 3, 1 is there. So what this kubelet is doing, it will start pulling the image. Like this process will take time, right? Take time in the second in sense is like if you must be using some image to create that Docker container. That image must be somewhere. So the pulling operation will start. The image will be pulled. Now at this point in time, when it is not created, but something is going on, see, status change will happen there. Like the pod is getting created, there is a status change as such. Step number 10. So now image will be pulled, the container will be created, everything will be running, and so on and so forth, right? In whatever time it will take, sometimes it takes milliseconds, seconds, like that. So after that, the status will change. The pods are running now, right? 3 pods are very happily running over there as such. And if something goes wrong, we have controllers which will kick in, and those controllers will basically understand that there is a difference between the desired state and the cluster state. Like desired state is what you have specified, cluster state is what practically is there in this point in time. So the controllers will kick in, and they will again, you can say the process will repeat to start the auto healing process over there. So auto healing is an inbuilt functionality as such. Like if something goes wrong, another pod will come up. Okay, so these were the fundamentals of Kubernetes as such, which we may require for our session. And just want to walk you through a couple of more things from Kubernetes fundamentals point of view, like how the services will find each other. Like how will these pods will find each other? Because in the code, the code is not the YAML file is not really very complicated, but it is using various elements over there. So whatever we discuss here, we'll be able to understand it easily when we go to the YAML files and so on and so forth. So I have this, we have in Kubernetes, we have services. I think this is where I have not numbered everything, so that's great. So I'll be able to do it with you guys. So right now, let's say this is one of the pod. So you see this is one of the pod over here. So this is pod number 1 pod, anywhere, anything. Right, this pod wants to talk to the other pods. Those 2 other pods are here. These are the other pods. You can say front end, middle tier, or you can think of maybe the middle tier and the back end pods and so on and so forth. You can think in those 2 terms. Now, how will they find each other? The problem is the first pod is now just FYI, the Kubernetes cluster in Azure can be having 100 nodes, right? So 100 nodes are there. So 100 is a big number. Now, if you have, let's say in those 100 nodes, the pods are running in this first one is running in node number 1, the other two are running in node number 66 and 77, right? So how will they find each other? How is the service going to how will the communication happen? How is the service discovery going to happen? What happens if one of them goes down and comes back again? Then how do they find each other? If the IP address changes, then how the communication happens? So for all of this purpose, we have a concept called as services, right? So we create these services over here. So you can see I have just colored them in this gray color over here. So this service is basically, it's not really like a, so in the diagram it looks like there is a particular, it looks like a load balancer there, like which is there, but technically it's like package forwarding mechanisms are there. So this is just one hypothetical, you can say not hypothetical, but it's just a graphical representation of it, right? So what you will do, you will create this service. What service? For example, like this. So I'll zoom in. So let's say the service is myapp.default the svc.cluster.local over there. So this is the service name. This is the workspace name. The namespace name. You can have namespaces in Kubernetes for isolation purpose. And SVC is one constant as such. Cluster is cluster, your DNS zone. Now, when you create this, right? So when you create that, basically at the backend, some sort of okay. Let me slightly zoom out as well. You see these two pods are there. This one is running here. It is having 10.1.0.1 IP. This one is not having any IP, but I think it's a .8 is what we want to put over there. So let's complete that. This one is having 10.1.1.8 over there. So when we created this service, right, we specified that this based on this you see this the selector over here, the label selector, my app. So that same label is over on the pods also. So we have the in Kubernetes the communication or the way uh, you can say the service find the pods or something find something else is with the help of the labels as such. We put these labels. Now, because you work with the labels, you don't work with the IP addresses. So even if the IP address change, the label will remain same next time. So still the communication will establish between them. So we have like my app label over here. One is my app here, my app here. So what will happen in this selector? There is one thing called as an endpoint controller. What that endpoint controller will do, it will create one endpoint object at the you can say as such. What this endpoint object will have is information like this. See that the name is my app over there. What is the target port? Port of the pods. Like what is the target port of that? So right now we are assuming it to be 9376. And what are the addresses over there? So the pods are having dot one and 1.1.18 address over there like this, 10.1.1.8 like this. Now, so if so basically what happens if when the communication happens, these two are there over there. Now this information which you see over here, this information is available to various components which we have in Kubernetes. Like we have a DNS service in Kubernetes, we have kube proxies in Kubernetes. Kube proxy is something which was if I just zoom out for you, kube proxy was running on every node over here. See, this is, you see this networking component. This networking component is what we are saying as that kube proxy over there, like these networking components over there. Now, so how does it happen? So this is that kube proxy, right? It is having a name now. Earlier we didn't kept the name there, but you will notice that you see this kube proxy. What it does, this is totally invisible to the pods. It sort of does an intercept the traffic. So it intercept the traffic, and it can do many things as such. For example, it can you can do load balancing type of thing. You can direct the request, you can encapsulate traffic inside traffic, and these are this is what we call as the IP tables, or the virtual servers, the IP virtual servers. So now finally what will happen is this will intercept the traffic and something like this. Let's read those numbers over there. So this client pods want to talk to those two other pods. So proxy will intercept the traffic. It will ask the DNS service, the DNS service, do you know where is this? Where are these pods as such, right? Where are they? So this DNS service already got the information from the endpoint, the object which was created. It already knows where it is. So it's you can say response back IP address of the service that okay, go and talk to that service. That service knows it, and then that that basically get address, and then the connection is established to the service, and the service further sends it traffic. You can say the route gets the package get forwarded to the pods over there. So everything, all the communication happens using these services. Now, these were the fundamentals of the Kubernetes cluster, which we needed to understand for our session. Now, I'll just take your questions. If there is any question in the chat window till now, then I will tell you more about the flexible server. How is it different from what we used to have, and so on and so forth. And then we'll start with the demo, and we'll go in more depth, and we'll take more elements. So before I go into more elements, if you have any questions which comes to mind in this, what we have in the screen, please put that in the chat, right? Can we have a single pod in AKS? Can we have a single pod in AKS in full AKS? You can have one single pod in AKS. The only problem will be it will be you can say AKS is suitable for microservices, right? Like container orchestration solution. If you want to run one single pod, run it in ACI, Azure Container Instances. You can run it, but that one single pods, how will you justify the cost? Daemon set. Okay, we'll go to daemon sets. We will, let me see if there are more questions. Okay, so in the meantime, put your questions in the chat. In the meantime, please notice this. So, and let me open the Azure portal as well. So want to show you something. Okay, notice this. Okay, there are some more questions about kube proxy. Okay, I'll repeat that. The, let's say, core DNS service. Okay, and how can one service with server nodes? Okay, that last thing is on the one service. Okay, service is nothing. It's a, you can say, globally, you can say the cluster resolved mechanism. The core DNS, the DNS which you are talking about, DNS and the kube proxies, they have those understanding. Okay, I'll take those questions, but let's stick to this first. Check this out. Okay, now if I take you to one of my resource groups over here in Azure, just want to show you something. So I'm going to my database. This is my this is one of my backup in case the demo doesn't run in the live scenario. Demos don't generally have issues in the live scenarios, right? So this is one of my backup over here. Okay, so this is the backup Azure database for MySQL, and I'll just click on it. This is the one which I have already kept running over here, and I'll zoom out slightly so I can also look at the screen. It's too zoomed in for me. Okay, now, so this is how it sort of looks like. It's an analogy which Microsoft gives, and it's a very nice analogy to explain what does MySQL flexible server means, right? The analogy from Microsoft is something in this manner that uh, it's a sort of they have done a comparison, and you can check out in their documentation for that analogy, right? I'll just repeat that analogy which I recall from their documentation uh, and from a talk which was on the documentation. So the analogy is that let's say let's say in your state or in your city or uh, in your, let's say in your city, this driver the driverless cars, the autonomous vehicles are introduced. So they, what are your so let's say, are you comfortable with it or are you not comfortable with it, and so on and so forth. So the speaker asked the host about this question. So basically, the host answers that, okay, I'm not very comfortable with the driverless cars because they are driverless. I'm little nervous because of that. So the host basically, the speaker basically put some point arguments forward that that from when we do this transition from something where we have the control, like you make your own machine, you make your own server, and from that own machine and your own server, you basically are trying to move into a platform as a service solution, right? So let's say on premises you work, you have full control, or even in the cloud, if you go for IaaS, you have full control over there, right? Now, if you do a transition from this to a PaaS solution, right, which is more like driverless, right, which is sort of having a lot of things which are already taken care for you, right? So customers are at times very excited about the by by going towards the platform as service solution. However, there is a type of it's good that there is less management to be done there, but that less management also leads to a lot of things which is being done by the cloud itself, right? So there is a you can say imbalance between the control which the customer wants and what is provided over there for the purpose of making it sort of run on its own. Just like the driverless cars, they run on their own. Autonomous vehicles, they are running on their own. So, like for example, to reduce that inflexibility of the driverless scenario or something which is running on its own, to reduce that inflexibility, if the person who's running it gets the option to select what can be taken care by the cloud, what I can take care on my own, that particular prospect is very interesting. Like I can decide, okay, cloud, like these are the 300 plus. I never counted all of them. There are around 300 settings are there, give or take, like around 300. So I'll just say 300 plus settings as such. So there are around 300 plus settings as such, which we can go and select. Like, okay, I want to manage this. I don't want to manage that. You take care of it, right? Or I will give the min max. You take care of it between the min max over there. If something goes wrong, do this. If that happens, then do this. Backup on my frequency. So retention, default 7 days. I want 35 days. Set 35 days. So the customer is able to use those 300 plus settings which are there, and with those settings, they can select themselves, even in the PaaS solution, what they want to drive and what the cloud can drive. This is what that flexible server provides. Now, MySQL is a very, very popular, you can say, relational database solution, which is extremely, you can say, popular. Plus, now we have it in the cloud as well. So if I take you back to this, so this is what I meant, the server parameters over here. So it will take maybe 5 seconds for them to load. Okay, yeah. So let me see if I can zoom in from here. So, okay, so let me just show you. Okay, you see this? These are those 300 plus settings which I was telling you about. So if you click on the server parameters, they have given the flexibility now to the customers that they can decide what happens and what doesn't happen, right? What they want to control, what cloud does, and yes and no type of thing, like what can be enabled, what can be disabled. So auto incremental, some sort of backup log, then some sort of, you can say, if I randomly click somewhere, then we have more settings around the flush, the synchronization flush over there. Then control the balance between the asset compliance. There are settings which number of iterations for which the database keeps the previous calculated snapshots, right? Like this. So you will notice that number of bytes to use when sorting data values, the size of the metadata lock cache over there. Then if I just see if I can show you some of the last ones. So here, the default transaction isolation labels over there. Uh, so now uh, this much of flexibility was not there earlier, to be honest, right? Now it's not that customer always want to go for this. There are two deployment modes. This is flexible server deployment mode, and the other one is single server, like where this flexibility is not there. Like you run it in the pure PaaS manner, like what you understand as PaaS. Like it's like more or less I have very less things I want to manage and let the cloud take care of it for me because I my developers wants to be more productive. But here the developers, if you go for the flexible server deployment mode, the not the other one, the single the non-flexible one. If you go for this one, then you get these 300 plus settings over there, which you can set based on your requirement. Apart from this, you can also put the replication. Uh, this replication I'll come to in some time. This replication is actually the read replicas. Like when you want to scale out, let's say you want 10 read replicas, uh, or 5 read replicas, one write server, 10 replicas. So you're getting it right, like a server cluster over there, right? So this is that option. I wanted to click on this one, not that. Maintenance is basically you can specify the custom schedule. Like this is a PaaS solution, so the maintenance will be taken care by the cloud platform. So when do you want that? What is your time when you would like them to patch the database in case something goes wrong? Most probably something will not go wrong, but just in case, what is the time at which you are comfortable? uh, so the time is also flexible. The maintenance time is flexible as per the the customer's need. Now, apart from this, the backup and restore, you can also specify that I want to the default retention time. All the backups will be, you can say, will be listed here. Only one seems to be there right now. It takes one backup every day by default, and it retains for around 7 days by default. I can increase it till 35 days also, like that. So we can have various frequencies of backup as well. You have to set your own frequency, but you can see things here you can restore in that point in time when the backups will be done. Apart from this, if I click on the diagnostic settings, you see this, the slow the slow running queries are logged as such. So you can specify, you can put your own uh, you can put your own criteria as what you, when based on which criteria you consider that the query is slowly running or not as such. So when if I click on the, let's say, logs over here, and if I go back to diagnostic settings, what we have to do is we basically have to configure it. So diagnostic settings, if I click on this add option over here, you will notice that we have these options, right? Log analytics workspace, archive in storage account, or let me untick it, or stream out using Event Hub, which is Apache Kafka based solution, or use some third party partner solution. So log analytics is the log analytics solution in Azure, where we do where it gathers all the logs and the metrics as such. So if I select something like this and I select my log analytics workspace, which I have to separately create, then all the logs are going there. There I can go and create dashboards. I can run the queries. I can create custom queries and so on and so forth over there. So one is already selected right now. This one I created just before the session started. So this is the one where the things should be going. Okay, you see these workbooks over here. These workbooks are like, some of them will be default. Some of them rest you have to create. So for example, if I click on something which is existing, it is showing me that this workbook is having some query load frequency. So what is uh, the query load time, total active connections, and query slow query details, and show the slow query details and so on and so forth. Those are yet not populated over there. I have not executed anything as such, but you can understand how does it look like. So that flexibility of the of you can say selecting your own. So now if you really think it through, right, you have the control as well. You can select what you want to do, what cloud can take care of for you, and you still have a very you can say um, you have a relational database in the cloud. This is what that flexible server offers, which we have over here. That MySQL flexible server will be having, you can say it works on the premium storage account, the SSD based storage account, which is there for low latency. And this configuration which you see in the screen right now is the local HA1. This is not the regional HA1. I think that one is below this diagram. So you see in the same availability zone over here, uh, in that same availability zone over here, the you can say it's made high available over there. Now, what happens if I don't want that? See, uh, this configuration right now is what we call as like local HA configuration, like it's in the same availability zone. So it is the nodes are you can say the compute is running on multiple servers and everything is distributed over there. Multiple copies are there, like 3 copies of your of all the components. But what happens here, performance will be very high, but high availability is less, right? So some customers who may have another alternate solution for their for the purpose of DR or for the purpose of high availability in case something goes wrong, then where the failover will happen. For those customers, this may still be okay because it will provide them with the absolute best performance from the database point of view, and it will provide them some acceptable high availability number, and their other solution will take care of the you can say further failover in case something goes wrong. But when you want more high availability, you basically go for the other one where we have the zone redundant storage, sorry, the zone redundant server, and which is over here. I'll zoom out so it can fit in my screen. Okay, see, like that. So in this configuration, what we are doing is this is where the primary there is a primary copy, this one, and the standby secondary copy. The primary copy and the other one, right? Now the this is synchronous synchronization. So it will it's synchronous in nature, right? This is like that. It's not asynchronous. So even if the primary goes down, which is in one location, the other one, sorry, this is still the same diagram where we have it in the same availability zone. I think the other one is below this then. So just to show you that this is the hot one, and this is the standby node right now, and this is the one which is being used, the read write copy, and that's the one which is for the purpose of standby synchronous synchronization. If something goes wrong with this, this is the one which will be used. Now in the same availability zone, so I'll just zoom out and see where did I have placed the other diagram. Okay, this small one over here, this was the one which I wanted to show you, and that was the extra one. So let me see if I can just move it, or no, doesn't want to move. Okay, so now check this. So here we have two availability zones, 1 and 2. Now I'm pretty sure you already know about availability zones, right? In the regions, we have 3 availability zones. In around 26 regions in Azure, we already have 3 availability zones. And in other regions, they are still making it. It takes time to build these availability zones. Now, one availability zone can be data center or more, right? One availability zone can be one or more data center. 3 are there in one region, and in out of 60 regions, 60 plus regions, in around 26 plus regions, we have three availability zones. In rest, they are still under construction. Now, if I just, for example, imagine this to be East US, right? So this is your primary server, and this is the other availability zone. And there are availability zones are in multiples of 10 miles away from each other. Like this one will be approximately in multiple of 10 miles away from the other one. But that definition is not always applicable. Like sometimes they are 18 miles away from each other. So it's not really multiple of 10 miles. Then the other definition is in terms of latency. The availability zones are 2 milliseconds away from each other. Like if you're sitting in one of the availability zone, you can reach out to the other availability zone in within 2 milliseconds. So but things are synchronous over here. So if I do this configuration, no problem. But consciously, I know that the performance of this will be slower versus the previous one, and plus the cost will also vary. The cost will go up in this scenario, and it will be slower. But yeah, this is more high available, more HA, and minimum it will provide me 4.9 high availability, like that, like this, right? So consciously the architects will think it through, like what do they want. They want the extreme high because it's synchronous, and it's syncing in two data centers, two availability zones which are in multiple of 10 miles away from each other. So obviously it's going to be slower than the previous one, right? Which is where all the copies were in the same location. So that trade-off you have to decide based on your scenario. Like, do you want absolute performance or what do you want? Okay, now there is another very interesting thing which I want to show you from the flexible servers point of view. And this is one of the Microsoft report which I have, which I found, and I want to share this with you. Let me see if I can just share this out link. Will it work or no? Yes. Okay, great. So this link, is going in the chat, right? So the enterprise strategy group. Okay, the economics of the economic value of migrating and modernization on-premise instance to MySQL database for Azure. Basically, they are doing a migration, right? So this sheet is the one which you will show it to your customers, or this is the one which you will show it to your managers when you have to during the TCO calculation, the total cost of ownership calculation, during the initial phases when we are planning, should I even go to that or not, right? Should I even go to that or not? So now, and this is a report from Microsoft. You can just download it and use it as it is. There are a couple of features which are very important, which they have highlighted, or there are a couple of interesting things which they have highlighted here. One of that interesting thing is, just give me 1 second. Let me see if I can open this in Edge, so I can also maybe highlight it. So I can also, yeah, okay. Not sure how to do that in Chrome, but in Edge, we have this here itself. Okay, so check this. So if you just go to MySQL, just go to it. Don't nothing else. Just go to it. 48% cost saving. Just upon your migration to MySQL, around 48% cost saving is there just on the default migration itself. Now, and there are a couple of interesting things which I want to show you. That flexible server is what we are also talking about right now. I'll just scroll down to the main part. You can read the entire report. Okay, the yeah, okay. So elimination of hardware is one of the reason why cost saving happens. Secondly, the elimination of the infrastructure related cost, for example, the 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 power saving cost, the cooling, and the flooring cost, and so on and so forth. All of that is eliminated. That is also the reason why cost saving comes. The elimination of the hypervisor happens. You're not running the SQL, MySQL on-prem. You're running them in the cloud now, right? Reduction in the MySQL commercial subscription. So if you go for the commercial subscription, that one is, you can say, also getting eliminated over here, or the cost of running the MySQL is part of the offering in the cloud as such. Now, apart from that, you have no, or you have control on the infrastructure you want to manage. You can let it be in, you can say, okay, cloud, you run it for me. I don't want to configure any server parameters, or you can control what you want to manage, what cloud can manage for you in the pass mode as such. So based on that, the efforts will be calculated in terms of no infrastructure management. Now we have the flexibility of managing somewhat PaaS solution. If we don't want to manage it, we are totally fine with it. Now the customers, they report that by just going for the PaaS mode, around 25% reduction was there in their in the resources which were utilized to manage the environment. So there was a 25% reduction. Like this, these resources can be human resources and other non-human resources as well. Now, simplified security and availability. The clouds are very secure. It depends on you can say, on how you have designed the solution, how many layers of security have you put over there. The security is always in layered approach. So the more the number of layers, the more secure your environments are. Okay, so if I just maybe see if there is something else which I want to show you. Other things are also there. The obvious things, that faster time to value, the faster migration, modernization, application performance can be tuned, auto scaling can be done, flexibility for the business, and integration with Azure services is very seamless. Deployments velocity increases, the integration with Azure DevOps solutions, and so on and so forth are there. These obvious things are also there. And okay, this is this is one of the graph over here. And now one of the interesting thing is, if you're going for this, you can also go for the reserved instances in Azure. If you are running something for a longer period of time, like let's say 1 year or 3 years, you can reserve the instances, in a sense like it's a type of you can say discount model, where if I say I'm going to that I it's like a commitment which I'm doing to the Microsoft, that okay, I will run my server for next 3 years. So based on that commitment, there is further cost reduction. And if I remember the numbers correctly, around 62% cost reduction will be there just by using reserved instances. It further increases as such, right? So apart from this, like further calculation can be done. Reduction is there. So okay, great. So right, so this is one report which you can keep with you, and you can use it whenever whenever you need to understand the importance of the MySQL flexible server, right? So server parameters plus cost reduction plus the ease of use and so on and so forth. Okay, so let me just quickly see if I want to walk you through something over here or okay. Okay, so let me just take you to my demo now. Let me just put those things forward, like what are we going to do over there now. So check this out. Now we will be this is Azure subscription. We will be creating one resource group over there. So imagine this dotted line to be the resource group, or let me just remove that. It will be easier just to imagine the white screen to be the resource group. Just imagine this white background to be the resource group, right? Now inside that resource group, we will be deploying one Kubernetes cluster. So in the same manner as you understood, we will make one Kubernetes cluster, and it will be having the master and the worker architecture. So something like in this way. Right now it will take some time for it to come up, so I will start doing I'll start with the deployment on the way, and when I click on like start when it will start getting created, because it takes some time to create, then I will come back and show you the next of the steps which we'll be doing here, so we can use the time, and we don't have to wait for it to uh, we don't have to wait for it to basically get created over there. Okay, so let me find the Visual Studios. Okay, so Visual Studio. Okay, so let me zoom in for you. Okay, I may have just connected with the cloud. Uh, I'm using both CLI and the PowerShell commands. So I have already installed the CLI and PowerShell in my laptop, and I have connected to both of them because sometimes I'll be using the CLI command, sometimes the PowerShell commands. And just one food for thought. Uh, Try to use the try to use the PowerShell commands, and inside the PowerShell commands, whenever required, you can call the CLI commands as well, and the JSON templates also. So the PowerShell behaves like that wrapper, which uh, which can run the CLI and the JSON inside it. So it becomes easy for or more flexible for your developers to develop. Okay, now today we are not doing anything so complicated. We are just creating a couple of things. So we have logged in into, so this is how you log in into Azure, into the CLI, into Azure for CLI. And this is the PowerShell login, Azure PowerShell login. So log in to Azure from PowerShell or for PowerShell, like that. Okay, now, so what I want to do is I just want to create one. Uh, just give me a second. My laptop is getting stuck. Let me see. Let me see if I can remove the Docker instance or something. Okay. Let me think it through. Okay, I'll disable the GPU. I think that may be okay. Anyways, so check this out. So we will create one, create resource group in Azure for our purpose. So we are going to do it Azure group create, and for the purpose of location, East US is what I'm going for, and the name of my resource group will be something. So we are going to do my resource group or let me say WordPress resource group, WordPress RG over there as such, right? Now I'm using this extension, which is one PowerShell extension is there, one CLI extension. So I am able to use the shortcuts like Shift. Like I have created some shortcuts, so it runs the commands in the bottom of the page over there, right? So you may not see me running it, but it's sort of running it on the bottom of the page over there. So the resource group got created. Now what I want to do is I just want to create the Kubernetes cluster. So because it will take time, the Kubernetes cluster. So we can go back to the whiteboard in the meantime. Now, how do you do that? Easy. We can do it from the UI as well, but that definitely you can do. It's just go and uh, you can say click on the UI, and I can also do it from the command line. So this is my CLI from where I'm creating it. Now in the same resource group, so I want to do it in this RG. So I'll put that over here. And then I have to give my cluster name as well. So it can be, let's say, my AKS WordPress cluster, like that. Now, and how many nodes do I have? Do I want? So, like these nodes are representing the number of worker nodes which are there, right? So these are the bottom ones. If I these two, right? So let's see. I'll put two over there, or I'll do one thing. I'll just check. Okay, I'll just show you a couple of extra things. See, if you want to check the quota limits of your subscription and so on and so forth, you can. These are my demo accounts, right? These are not the production ones. They have quota limits over there. Limits are in all the accounts. You just have to. It's possible that some of the limits are more or less in various accounts. So this is. I was not sure what's the limit in my subscription right now. So I'm just going to the quota part over there. I'm just selecting the East US. I don't want to see the other one, and I just want to see how many uh, the resource provider will be like compute resource provider. So based on that, I just want to select the node because otherwise the error will come after. I think it should be okay. TS2 family, and let me just quickly think it through. And I didn't thought it through earlier. So let me just quickly see the backup AKS which I created for my work. In case something goes wrong, it is of DS2 family only. So we have a pretty secure DSV2 family. Yeah, okay, we have enough quota with us. 30, we can easily make the node count 2 or 3 or 4 or 5 and so on and so forth. So, right, so generate the SSH keys and seems fine. So I'll just run this and like that. It will take some time. Let me see if there is any typo somewhere. It should throw the error. It's not throwing any error. Okay, let it run. Now the AKS cluster is coming up, and the this is coming up. Now what we have to do is we are also creating one ACR, Azure Container Instance, so Azure Container Registry over here. This solution like this. Now what ACR will do is this is the this one. This is called as Azure Container Registry. It's a repository for images. It's basically an image repository. Image repository over there. So we will be pushing the images there. The Docker image which will create, we'll push it over there in this one. You can also use Docker Hub, right? So we are in Azure, so I'll use the best option which I have. And so something like this is what I want to do over here. This is I have Docker desktop in my laptop right now, right? So something you can imagine it to be like that. Now I'm doing it manually right now. If you join us, if you have seen any of our previous sessions where we were talking about the CI/CD pipelines, the output of your CI pipeline, the artifact that CI pipeline can also do it, right? So, but right now I'm doing it manually. Watch a few of my previous sessions as such. Now The okay, so now WordPress, I will just I have the zip file of the latest WordPress downloaded from their website. I'll show you from where I got it, and we'll create one simple Docker file. So this is Docker file, and this is the application. And using both of them, we will create the image like that, right? Like this. So this is the WordPress image with all the dependencies will be there. We will tag it. Some tag will be there, and then we'll Docker push it. Docker push over there. So we have to create, we have done AKS, this is done. This we have to create, that we have to download and so on and so forth. This we have to create, this we have to create, and then we have to push that, right? Then we can do the rest of it. So if I start with the easy part first, the ACR creation, the one which will take more time, not the easier one, because okay, still going on. So I will do that later on then. And let me find that link which I gave in that. So in the chat window, I have I gave you a couple of links before. I'm using one of them only. Uh, as such, I'll put those links in the chat. Those who want to reproduce what we are doing right now, those links are in the chat right now. I just repasted them. Use them right after the session to reproduce it. Now I'm just going to one of them to find the. Mm, let me just show it to you. Give me a second. So I'm just looking for that link from where I downloaded the WordPress. Yeah, latest WordPress. Over, okay, from here. So latest WordPress, this one, download and install this one. So I downloaded that, and I'm just going to use the one which I have downloaded earlier, and let me find that in my secondary screen. I'm going to this folder over here, this one, Kubernetes demo folder. It's in the documentation, documents, live. Okay, found it over there, and I'm just extracting it. In this point, I will just extract it here only. Okay, so let it do that. Now, anyways, this one we'll remove. We don't need that. Should have not put it there. But okay, the Kubernetes cluster came up, and things are happening parallelly. So I will just go back to the whiteboard. So just to keep you in touch of what I'm doing. So this is ready. This we have to create. Let's do that, right? Then we will proceed with it. And just creating that is not enough. We have to connect it as well. Like this needs to connect to that. So if we don't connect it, then later on, when we will try to pull the image, when we will try to do the ACR pull operation, then that operation will not happen, right? Or some error will come and so on and so forth. So that thing we want to take care of. So let's do it. And I will also see if there is any question apart from what we were there in the chat window earlier. Okay, what is kubeproxy? Kubeproxy is the one. It's a networking component basically. Uh, it is the component which was intercepting the traffic when the pod was trying to talk to the other pod. It runs transparently over there. Okay. Okay, so let's create one ACR. Create ACR for storing the images as such. So the command is basically Azure ACR Create. CLI commands are easier to remember. Easy ACR Create. Then we have to specify the name of the resource group. Like it's generic. So resource group name was uh, WordPress RG, and I think yeah, this one over here. And the name has to be globally unique as such. This name cannot be the the old one. So I am just going to give it some name. Let's say I'll use my name, ACR, and I'll put one random number there just to make it unique like that. Okay, so one ACR is coming up, and after ACR, we will create the flexible server as well. So now the MySQL server, right? Flexible server. So I will just put it over here. SQL server. Now again, in the same manner, the command will be az mysql flexible server, a flexible hyphen server like that, and then create. Then I have to, okay, now in case I would like to whitelist the IP addresses. I'll do one thing. I'll whitelist it afterwards. I will show you how do I whitelist it because right, I'll show you that afterwards. I will not whitelist it right away. All the databases are protected by firewalls, right? If you when you will maybe hopefully you will go through the advanced networking concepts one day. So for example, this is what we are trying to create right now, MySQL, and this MySQL will be having a firewall over there like that. So we would like to whitelist things. Even I myself, my laptop is also not whitelisted over there, so I can whitelist me. We can also whitelist the Kubernetes address range. Now Kubernetes cluster, it's running in its own network right now. So if I just zoom out and show it to you, imagine one VNet like this, like that, right? One VNet like this, and subnet inside it over there. That is where the Kubernetes cluster is running. So that is also not whitelisted. It will not be able to communicate with MySQL. So there are many things. Just remember one word. The best way of the private connection will be using private link and the private endpoints. Right now, it's not the concern or the focus for the training. So I'm not creating a private link or private connection. I'm just going to the firewall and I will whitelist the IP addresses so they all can talk to each other. So it reduces the complexity. Now, the screen share seems to be lagging. Uh, is it? Okay, let me know if that happens again. Now, so this one, we'll see if that MySQL server is up or not. I will just go back and see, did I clicked on it? No, not yet. So the name, we'll give it a name, and name can be, if I'll just see what random name does it take. Okay, so it will take one random name. Great. AKS WordPress exist. Yeah. Okay, so it is coming up. It will take some time to come up, and it is anyways asking me to whitelist my IP address. So yeah, great, do it. Then if you just want to do that. Okay. Now ACR is ready because we can see the prompt came back. Right. So in the meantime, we will do this connection. We will do this red line. We'll connect ACR with AKS. That line we'll do in case in the meantime, flexible cluster is coming up. So we are going to attach ACR with AKS, the red line which I was showing you. So now to do this, first of all, I have to get the credentials of my AKS cluster. So what I'm doing is I'm doing AKS AZ AKS get credentials. Now what this get credentials will do is what it says, get credential, and then resource group is my WordPress RG over here. And the name of the AKS cluster was something else. So we will find that the name of the cluster here over there. So I'll just click on it, right? So this is the next command which it will run after flexible server. I have already executed it. Now after that, once it is connected, now this is the one where the credentials will be, you can say, retrieved from the Kubernetes cluster. Now I'll just connect my that red line which I was showing you. I'll just connect both of them. So that connection is basically one update command which I have to execute. And let me see if I remember it correctly. While I look at my secondary screen where I have the previous one, AZ AKS update, and the name of the cluster, which is that. And I'll just put it here. And then the name of the resource group. So which is basically here, and then the name of my ACR. So this ACR name will be that over there. Now the FQDN of this is Shivam's ACR 987875.azure.cr.io. There is no need to give the FQDN. Anyways, they will omit that. They will internally understand it. So I'm executing this command as well. So what it will do, this will get the credentials of AKS. This will basically attach my ACR with AKS. So this red line will happen. So we have AKS, this part, and that is coming up as we are speaking. So if it is ready, we'll just go and do the whitelisting of the IP addresses, right? We'll just go and see it over there. Let me just quickly go to Azure and see if it is ready. So we don't have to wait for it to totally completely deploy. If the networking part is ready, if it let us save it, that will save us some time. So no, not yet. Okay, so we'll wait for it. And let me just read the output once. Sorry, let me read this. Yeah, it will take some time. Okay, in the meantime, let's do the rest of it. So what we're going to do now, this is coming up. We have not done the firewall whitelisting yet, but we can do this part. I have the WordPress already extracted. I'm going to do some modification there, and then I am just going to show the Docker file to you, and then we'll make the Docker image, and we'll do the Docker push operation, and so on and so forth, right? That part. So let's do this, this and that. I'll take you back to the WordPress, sorry, to the Visual Studio, and let me just parallelly go to that location in my secondary screen. Let me see. Yeah, okay, great. Okay, so I'm just going to do some renaming over here, and let me see. Okay, so my WordPress app, and apart from this, let me do one more thing. So okay, I'm just restructuring my the folder structure. I am thinking it through. What should I do with it? And let me just see the structure here once. Let me just come outside and have a look at it. My WordPress app. And okay, fine. Seems fine. Okay, now we will just create one Docker file as well. There is one more thing I just want to do over there. So let me do that. I just want to put the Docker file inside over here. So let me just quickly think it through. Such. Now let me remove this, and I will create the Docker file here. Okay. So public. Okay, fine. And okay. So let me see where it went. No, it got inside. Let me move it outside. Okay. Let me do that in my secondary screen so it sort of happens little more fast over there. Okay, great. Now, okay, so if I will just go and see, okay, now check this out. So we will be working with, this is my Docker file. So what we are basically doing, we have the content in this folder called as public folder, which I just created, this one, and everything, and this we are copying that into this path, and we are installing the couple of things inside that MySQL, Docker, PHP, install MySQL CLIs as such. And then we have the base image over here. This is a Docker file. And what we will do is we will close that. And apart from this, I don't want to make any other difference. I just want to show you the YAML file now. So the okay, and some of the previous things seems to have gotten into some issue. I don't not sure why that why is there. We'll go and we'll check it. But let me just quickly make the another file over here. So this is the my WordPress, let's say .yaml over there, and I'm just gonna put something. Oh, not that. I'm just gonna copy something from my secondary screen. I'm just gonna put something here. Okay, we'll come back. We'll see what that is. Let's troubleshoot what happened here, and then we'll go and see that. Now the okay, great. Something. Let me read that. Could not be found. Yeah. The so AKS update resource name Shivam's Azure CR.io. I remember this same issue happened with me in one of the previous demo as well, uh, and it just magically didn't work that day itself. Okay, so let's see, is it healthy or not? What went wrong with it? So I'll just take you to the resource group, and I will see into the word over here. That's the name which we have given, isn't it? Then let me just take that name back again and just put it here. Okay. Or no. Okay. So I will tell you the oh, seems to be working. Okay. Not sure why I'm so lucky. Now what generally happens is sometimes this happens. It happens because of the resource is not found. Then the resolution is the resource ID. You basically have to use the resource IDs. For example, if I show you what I mean by that is I'll just show you the resource ID. You can find the command for it. I'm not sure. It luckily seems to be working, uh, but the backup is this. Like you go to the property section over here, or any. Let me show you what do you mean by the resource ID. Let me see where from where can I show you that. And the property section like this now, and then there are like FQDNs over there. So you see this like that. So it goes in depth, like it says like subscription slash subscription name, so number, the subscription ID slash the resource group, the provider, container services, cluster name. So if it is unable to find it, generally we the using the resource ID will resolve it, right? Uh, Happens. Okay, so seems to be going on now. We will just go back and recall what we have done in the whiteboard, and then we'll come back and see, go back to that, because the demo might be a little more complicated because we are not taking any linear approach right now. So I have created this Kubernetes cluster first. That's the first thing which I have done. Second thing is the ACR is ready. It's already up, and right now the operation is going on where we are connecting these two. That's what we are waiting for, where which is going on. The flexible server, we'll go and see, is it done or not? We still have to whitelist the IP addresses and so on so forth in the flexible server. So I'll check that part immediately. I'll take you back to my Azure portal. We'll go back and we don't see anything here. So we will search here and I will see. So, oh, I seems to have done some sort of maybe it looks like we have created another resource group for that. What was initially we were using this WordPress RG and then we were working very well with it. Then somehow over here we use another resource group. Okay, so great. Now we are doing the update using that resource group. I should throw an error. Uh, Luckily, I'm not sure how it worked, but the Kubernetes cluster was in that one. Okay, so that's why it worked. And the resource group is different, and that's the AKS name. That's the WordPress. I'm just reading it wrong. Okay, it's fine till here, but this is different. Okay, so I think I by mistake I copied the name of the. That's my AKS cluster name. I should name it properly. Okay, now so it went in another RG. Okay, no problem. So we'll just put that in the diagram. So I don't I remember it. So you see this guy is in a different RG. That's all over here like this. So that and by mistake I copied the name of the AKS cluster as the name of that RG over there, but I was supposed to copy the name of the RG as the name of the RG, but yeah, happens. So no problem. There won't be any issue because networking doesn't depend on resource group. So we'll just go back to Azure, see, and I'll close the unnecessary tabs which I have. Now I'll find I'll find that again. Let me go back and find the that again. So this should be the one because that's the name of the AKS which we created. This should be the one. Now, what I want to do is I'll take you to the networking section over there. And okay, so you see this. Let me zoom out somehow. Okay, now I'll take a shortcut here, but I'll tell you the long way around as well, right? The long way around is this, or the correct way around is this, which in maybe in some sort of security networking security uh, session or right event, you can go and have a look at it, or just look up in the documentation, right? So this is that's Azure VNet, and this is a subnet over there, like this, right? So this is VNet. This is the production way of doing it, right? And we will be taking a shortcut right now, and this is the subnet, like that. And the cluster is here right now. Everything is, you can say, uh, it's over there, like this. Imagine, right? Now, the PaaS solutions of Microsoft or the PaaS solutions are not inside your network. They're outside your network, like this. So here, all the PaaS solutions are there, like this. So imagine some data lakes are there, storage accounts are there, right? Databases are there, and so on and so forth. Like some databases are there. So the problem is the PaaS solutions are not inside the network. So which is pretty it's not no one will go for it in the end of the day in production because we have NSGs here, the network security groups, the ones which are going to protect your network. These are the ones which will say allow the traffic or deny the traffic. No, you can talk to each other, you cannot talk to each other, and so on and so forth. So they will allow and deny the traffic. But now the PaaS solution is outside the network. So how will the NSGs apply there? They will not apply there, right? So what do we do is basically we have provisions around it. So there is a provision which is called as private link and private endpoint. So private, I'll just write it properly, and then we'll just skip it, right? So private endpoint. Now what private endpoint does is you imagine it like this. You see this? This is private endpoint. Now this private endpoint will be getting the IP address from your subnet range. So if this is your subnet range, let's say /24. Don't get confused. I don't want to spend time into this, but those who are comfortable with networking, it's okay. Otherwise, just anyways, we are just skipping it in 1 minute. and /16, right? So this is getting one IP address from your subnet range, like something like this, 0 dot maybe 6 or 7 or 8 or 9 or 10 something, right? Whatever. Now then you see this neck which I'm creating, the red line, the red neck, this one, this tunnel which I'm creating. This is called as private link. So private link. So now if we do it individually, it's not like for everybody it's one. Like for that it is now. So now, right? So so now this diagram can be simplified as this diagram over here. If I simplify that diagram, I can simplify it like this, and it will still be correct to represent it over here. You see this AKS cluster, and then these are your PaaS solutions. So effectively, by using the private link and private endpoint, the PaaS solutions are now effectively inside your cluster, sorry, inside your VNet over there, or inside your subnet over there, not VNet, inside your subnet inside the VNet as such. So this is what happens, and this is the one which is recommended in production. This is what you should use. Every PaaS solution should be, you can say, connected with private endpoint and private links. So there will be a specific cost for the private endpoint and private link. So look up in the pricing calculator for that. Now that's can also be done. It will just take more time to configure the network. But what we'll do is we will take one small shortcut over here. So I'm just going to whitelist the IP addresses. Now, if I take you back, see what I'm going to do is I am just going to do what they have said here. Okay. And I will zoom out and I will save it. So what I have effectively done is I have whitelisted the entire IPv4 range, not really recommended in, not never recommended in production, but for now I'm doing it. And the way you will do it will be with private endpoint in your production environments. Use that over there. Okay, so if I take you back to my diagram, flexible server is now, you can say, the firewall problem is taken care of over there, and it is accessible from other resources as such, like this, like that. Now, what we will do is, I think we just have to read the Docker file. We have read it. The WordPress extracted file doesn't have anything to read. It's like a WordPress dump. You can read there in. Go to their website and have a look at it. Like this is their website. What all things are there. I'll put this link in the chat window. And right over here, have a look at it from there. Now, what I'll do, I'll just walk you through the manifest file. The manifest file is the file which, let's create the Docker image as well, right? We haven't made that yet. So using this and using that, right, we'll create the Docker image over there. So if I take you back to the to my VS Code over here, so let's create the Docker image over here. Now, basically, let me just quickly understand something. Where am I? Oh, it's not even printing it out. Okay. So, okay. So I'm inside. Okay. Okay. Then I think if I got it correctly, then this should work. So basically, we are just going to make it. So we are saying, okay, Docker build as such. And I have the Docker desktop installed in my laptop, so I will be able to do this. And the Docker file is not here. Docker file is inside the other one. So I should just go one folder in. Let me see. Yeah, okay. So Docker file, and then the name and so on and so forth. So I'm just going to put a tag over there. Without tag, we cannot push inside. We cannot push inside the WordPress, sorry, the ACR. So latest, and I think I have given this name before. So I'll say live latest, and that's all. Let's see. Let's try this. Okay, cannot be empty, is it? Let's save it. So let me save that once. Let me try that again. Okay. Let me try again. Yeah, okay. So it should not take very lot of time, but okay. After this, what we are going to do is basically this operation. We will be doing we have already tagged the image. We are going to do this push operation. So this is where finally the WordPress image will be there. Here, here, all the dependencies will be there with the tag which we have given, which is called as latest tag, and that's the one which we are going to pull later on, right? Like this. In the meantime, this is happening. Let me just explain the replica servers over here. Now it's very interesting. How do you scale WordPress? Like if you practically think it through. See, by having multiple instances of the front end, we will be able to, you can say, achieve the load balancing requirements or the scalability in the front end of the app. You can say in the WordPress front end. But what happens about the database, right? Can my database also can be scalable? Can it have like you can say master worker architecture, or can it be having some read replicas and so on and so forth? So the functionality which we have with MySQL is, so this is Azure database for MySQL, database for MySQL, like this, right? So this is a read write copy, like that. What we can also do is we can create multiple more read replicas, like that. Up to 10 read replicas can be created. So like that, read replicas, like this. So how do you do that? We haven't configured it yet, but it was from the tab which we were looking at. Uh, if I just go one page back, it was on this tab over here, the replication factor from here. So from here, we can add replicas over there, up to 10 replicas. Now okay, one thing is the replicas are synchronizing in asynchronous manner. Remember that, right? So these are synchronizing in asynchronous manner over there. So, but together, you can say, if and then load balancing is taken care by them. They will take care of the load balancing over there. But these are your read replicas. So these are the read only copies, read only, and this is going to be the read write copy, like that. So the database can be pretty you can say uh, can be pretty powerful as such. Now, okay, so let's see, is it done? Okay, great. So if I just want to show you, let's say that how many Docker images do I have? Now, you will notice that I have, sorry, which one is the one which I just created? Oh, execution failed. Some exit. Okay, I'll check that. Okay, now notice this. So the Docker images which we have right now is, or what it should have done is this one, something like that. Like the or let me take care of that. Let me just take care of this. So the name of the ACR. Let's find that. This is the ACR new name. Let me find this. So what I'm going to do, the image which I already have built, I'm just going to tag it as such. So now I have the image which I want to use with the new name. This is my new ACR, this one, like that. This is the image. Now I would like to mm, push this into the uh, into the ACR which we have created. So Docker push, and I'll just use the same. I just use this from here, and looks fine. Let's try over there. Okay, so what this operation is doing is this red line which is here. It is pushing this Docker image into that ACR, like that. Okay, now and authentication required. Okay, so yeah, then I have not logged in, it seems. So I'll just do one thing. Before I push it, I will log in into, so let's say log in into the ACR. And this is where we have done the tag the image to have the ACR FQDN over there. That's the one. And this is login into ACR. Then we can push it. It's another layer of, you can say, I writes and so on and so forth, right? So name, and the name will be this name. So you forgot to log in. So they are saying you cannot log in. You don't log in, you cannot basically push it. So let's log in. And great. Now, please push the image there. So this is the Docker push into the ACR, which you have created like this. So, right now, it may take a couple of more seconds, but finally, what is going on is that the is basically over here. If I just go to my container registries like this, you see the bottom one is what we have created right now, that one. So the image is going in here, here, uh, like this. Okay, this one. That's where it is going, or is it already gone? So okay, done, pushed. So right, like that. Now the okay, so basically, if I just show you the okay, so what we have done is we have the image here. Everything is connected. That's also whitelisted. AKS is also in place. Seems like everything is in place. I don't think if I have skipped anything. But what I'm doing now is I will show you the manifest file, right? So we'll read the manifest file and we will apply that manifest file, something in this manner, right? So let's say apply to the API server. This is what we were discussing in during the start of the session. Like API server is the one which exposes all the APIs and so on and so forth. So API server there, and the entire flow will start like 1, 2, 3, 4, what we were thinking through. Now, let's go and have a look at that. Now, this is the one which I have it over here. Now, there are a couple of things which I may have to change here. So I'll also think it along with you over there. So this is the kind deployment which I'm doing. This is the metadata.name is the field which is specifying the name of the deployment. One replica is like literally one instance over there. You remember the labels which we were talking about, those labels, the label selectors as such. Now the template dot name, this is where we are specifying the container details, that the name of the container as such, and from which ACR will you take it? That should be the new name. So I'm just going to go back and I'll take this name from here and I will put it over there. That okay. The image is there. Container port is 80. Server name and everything got changed. So server name we haven't even copied it yet. So let's go and find the server name. That's the server name. We'll remove the space which is getting copied right now. And it goes here. Now you see the server name. This is the default username, I think. I didn't give it. So let's go and verify it, where it went. So one default username can be found like that. See, if I just take you to the overview section, you will be, no, it's different. Okay, so this is one default admin name. Password, I haven't even created that. So I will also have to reset the password. Now let me okay, the correct way of doing this, I will also explain the correct way. We're taking a shortcut right now. So in the meantime, it runs. I will tell you the longer way around as well. And I copied this. I'll take you back to the to this, and that's that. Now you see this. I have hard coded the password here. This is never, we'll not do it, right? But to overcome this, then I have the I have to take you back to my whiteboard, and it's the next part which we'll cover, which is over here, uh, with the how do you make it secure. So you see this, the identity services, pod identity, and the key vault. The key will be in the key vault over there, but that's the next part which is coming up. So I'll just show you the hard coded way, and then we'll see how do you make it secure over there. Now, if I take you back to this, rest is all okay. We have this PHP service over there, which is a kind load balancer. Port 80 is where it will work, and we have some. These are the environment variables which is required by the WordPress instance when it is looking for the uh, WordPress when it is looking for the database. That's what this is over there. Now, if I just see, if I just zoom out slightly, I will zoom out here. If it let me zoom out, okay. Now, uh, so we just have to deploy it, right? So let's quickly see if it is deployed or not. And let me see if I try to just let me see, where am I right now? Okay, Dockerfile. Where is my manifest file? It's okay. Yeah, this is the one, right? So let's deploy the WordPress in the AKS and so on and so forth. Right. Okay. So it's this is basically very straightforward kubectl apply. Now this kubectl also is not by default available. I didn't install it because I already have it in my laptop. But you have to have kubectl also installed in the laptop, right? You can either get it from their website also, or there is one command which I will just put over here, which I didn't execute it because I already have it. But it should be something like AKS install CLI. Install -CLI. If you do this, it will install kubectl for you, uh, right? And then only you can use kubectl, which is the which will not run if I don't have it. So, right, that needs to be executed before. Now we just have to okay, we are sort of done with this. Now we are going to apply that file, and the file name is my WordPress. This one, that's the file. Let's do it now. Once this gets created, great. So let's see, is it healthy or is it throwing some error and so on and so forth? So getting created right now. Okay. Okay, great. Running. I was reading this. Sometimes when you make any typo, right? For example, if I give a wrong image path here, let's say my image was called something else, I gave something else, then we'll get that image pullback errors will be there. So if that happens, then I thought that I will just come back and uh, change it over there and then redeploy it. So it seems to be okay. Seems to be running. Now we already made one public endpoint, so that we will use that one. So we don't know the IP address of it. So I'll just say get service, and that service name was something PHP hyphen SRV. That's the name which we have given here, uh, right? So that's what I'm just getting it, and by now I think it's uh, already there, and mm, so S oh sorry SVC, and I have written okay SVC. So great, right? So let me find the browser. Let's see if I can find the browser. And it's going to doing something there. I should open it in incognito mode. Let me try to get the browser again over there and so on and so forth. Okay, not secure. Yeah, we don't have the SSL certificate yet. Okay, so okay, what this will do is this will start the initial WordPress installation, that one, right? And once I fill it up, it will look like this over here, like that. This is how that default one looks like. I have just given the name reactor and over here, right? So if I just complete this particular diagram, we made one pod here, and this pod was the one where the Docker image is there right now. The container is there right now, and you see this. This is basically connected with that as we are speaking, and it's a normal WordPress website. Do anything with it, and right over there. Now, what are the improvements or additions which we would like to do over there? Before I go in that direction, let me just see. Let's go through the chat window once, and we'll see if there is any question till now. Right. Okay. So if there is any question which how did it connected? How did it connected is because the environment variables which we have given here, see these ones, these environment variables, the connection configuration here. That's how it connected. WordPress works with MySQL, right? It was looking for it. Okay, so uh, right now let's understand a little more things over here. Now this is what we have done, right? AKS this. Okay, now I'll take you back to what else we can do over there. If I zoom out and if I take you uh, further in my diagram, SSL certificate is the next thing which we can put. Now, SSL certificate, in case you are looking for how to do this, right? The SSL certificate part, there is a link which I have already given in the chat window. I can open it again if needed. I'll I can paste it again if needed, but this is where it takes you to this Kubernetes service workshop, right? So those who want to learn Kubernetes, it will take you some time. Do it maybe when you have time over the weekend, today, tomorrow, or maybe next week, and so on and so forth. But you will notice that there are this is not what exactly I have shown. I have just shown some bits and pieces of what we have done based on our requirement. But if you see, this is having way more structured deployment. You deploy Kubernetes service, you deploy the container registry, you deploy MongoDB, and I will show you the architecture as well. It should be in the first page. Then it's a three-tier architecture. So MongoDB, there is one rating API, and the front end is there. Then it will start working over here, but uh, then we don't have the SSL certificate there, so we are creating the SSL certificate as such in this step over here. So we basically create this. We use the Let's Encrypt, and we create one SSL certificate, and that SSL certificate is what we bind to the service which we have. So if you remember, it was showing connection not secure. That part will be taken care of. So over there. So if I just walk you through this entire diagram first, and then I just show you the certificate part. So the diagram looks like this over there. So it's slightly bigger. Don't worry about it, but it's pretty straightforward. I have it copied here. So there are three components in this architecture right now. First component is this one. You see this? This is one. That's another one over here, and this is a third component. This is a third component over here. This one. So this is the front end. This is the middle tier API. That's the database, MongoDB. Right? So DB over there. So like that. So those who want to learn more about Kubernetes, you can think about this, right? And what is this ingress controller? I will just show it to you. this ingress controller is something. Over here, I'll take you back to this diagram in another 1 or 2 minutes. So the ingress controller is basically here. So I thought that maybe we may be covering it. Now, if you notice it as such over here, this. So what happens is ingress controller is basically it will help us in achieving the layer 7 load balancing. There are two ways in which you can do it this in Azure Kubernetes services in two ways. First way is like how we are doing it in that workshop using Nginx. Nginx is used and it does the path-based load balancing, path-based routing plus SSL offloading for us. Right. So let's understand what it does, and then I'll tell you the two ways in which we can do it. And right. So what it does is layer 7 load balancing, like said, like that, layer 7. So we create the ingress controller. So we have to give the configuration. Let's say ingress controller. The incoming traffic will be for contoso.com. I'll zoom in a little more. Even I cannot read that page right now. Let me see if I can zoom in slightly over here. Okay, so imagine like that the traffic which is coming for you is the traffic which is coming for you is going to is coming for www.contoso.com, right? And you have a lot of different microservices which are hosted there. So let's say slash license renewal, slash license apply for the license, slash some other functionality like slash wish list, slash cart service, slash payment gateway, slash something, right? So contoso.com is that. Now, which path do you want? You can specify the path like that. Okay, slash images, slash videos. So there are different services for that. Like Contoso image is one service, Contoso video is another service. Now these services are discovered throughout the cluster over there. So if I just show you what I have here. So these are two services which we have: the Contoso video, which is the Contoso image over there. Now these services are sitting on top of the pod. Now pod might be in different, you can say different different nodes over there. So this is the pod number 1, which is my app pod 1, and there is another image image app over there, image app over here. Two image apps are there, and the image services is on top of it. And then we have this Contoso video app, and there are two apps. The two pods are behind it. So basically, this is how that architecture may look like. That ingress controller is basically going to, you can say, do the pathways routing in this manner. So when the traffic comes in contoso.com/images, it basically goes to the pods where the image logic is hosted. And when the traffic comes for Contoso image as contoso.com/videos, then the traffic goes to the uh, the other one, the video one. And somehow my screen is, the diagram is pretty big now, so it seems to be getting stuck, but something like this, like that. So this path-based routing is what we are trying to achieve with ingress controller. Now, to make this ingress controller, there are two ways in which you can do it in Azure Kubernetes services. First is you use Nginx, the normal way around. The second one is what I will tell you. The first one, anyways, if you do this case study, they're also using Nginx over there to work with it. The link which I have given, if you find some time to do that, you will be able to uh, see that. Okay, let me zoom out where it went. There, over here, right? Like this. See, so what they do basically, they create these Nginx pods over here, and these Nginx pods are the ones which are where that logic is what we just discussed. That logic is applicable or you can say is applied and so on and so forth. So this Nginx is providing that layer 7 load balancing for these various services which we have for the over there. Now, this is one way in which you have to do it. Now, the thing is, Nginx will be running in pods over here. So the pods, uh, basically, you need to run the pods also, right? Right, FYI, run the pods also. Now, if you know about some limits, we have some upper limits are there, like 250 pods per node. There is one of the upper limit like this. One of the maximum biggest upper limit is this. This happens when you use Azure networking. We call it as Azure CNI networking. like that. So 250 pods per node is possible. So like how many nodes can we have? 100 node cluster. So 250 pods per node. You may not be able to reach such a high level because of the sizes will like it also depends on the resources here, like how much resources do you have in your cluster. Otherwise, if you don't have the resources, you will not be able to reach that 250 pod limit, but that's one of the technical limit which we have. So now if I if the load increases, then I have to have these pods also increasing the ingress controller, and they also needs to be running somewhere. They also needs to scale out and so on and so forth. Now, if something goes wrong with them, and they are also inside my AKS cluster, can't we just use any Azure service to take care of it? So in Azure, we have we basically have uh, we have this service called as layer 7 load balancer called as application gateway. So this layer 7 load balancer, it's a PaaS solution first of all. So layer 7 called as application gateway, app gateway, and the nickname is app load balancer. So this is easy to remember, app load balancer, but the real name is application gateway. What it does is it does what Nginx will do. It will do the SSL offloading. SSL offloading is the termination of the secure connection which you it's the termination of the SSL traffic. It's the termination of the SSL secure. We have these words which we use. SSL offloading is one word. Another word is called as secure. Secure communication termination, like that. So it's basically where the decryption of the HTTPS traffic happens. So why should I do that? Decryption of the SSL traffic here when I can do it here? The reason you will do it here is either you are working on a healthcare application or in some sort of application which wants it to be end-to-end secure, then you can terminate over there. Otherwise, in let's say in other scenarios, the termination of the SSL can happen here as well, and we don't have to do it here in the service. So we don't have to utilize the resource of the service over here. We can say load balancer, you do it for me, right? Like that. Now, so it can do the SSL offloading. It also contains one WAF over there, web application firewall. So like this. So whenever the communication comes, this firewall will check for layer 7 type of attacks which may happen, like SQL injection and so on and so forth. So layer 7 attack, it checks for, it blocks it over there itself, and then it does the pathways routing. Anyways, what we would have achieved. So you can specify the path which you want. Let's say slash images, slash videos, and slash license renewal, slash card, slash this, slash payment gateway, slash order history. So these are your you can say pods which are running inside the Kubernetes cluster over there, and the request is going to them. So the ingress controller can also be created with the help of the load balancer which is there. Now this is going to run outside the cluster, right? This is your AKS cluster, and this is running outside it, right? Like this. So now this service itself is very high available. You can also say zone redundant. If you say zone redundant, it will become you can say uh, regional HA, like that. So this is East US, and these are three zones which we have. So it will be something like this, HA. Now, give me 1 second. Okay, sorry. So this is we can offload it. We can say U auto scale. It there is one setting over here called as auto inflate. Auto inflate. It will become bigger and smaller based on your requirement. So it's also scaling. It's doing pathways routing. It's now decoupled from my AKS cluster. I can use my AKS cluster for other purposes. So if you are looking for ingress controller with the so in Azure with app gateway is one of the recommended method by which you create ingress controller for your WordPress or non-WordPress requirements, and you can look up in their documentation for how to do it, the steps over there. And apart from this, I just want to take you to one last thing which I have over here with me, which is not that, but actually was this. So, right now, there is one change in this page. I'll show you the new page as well. This page has been changed recently. you see this pod identity. That pod identity has been the service has been upgraded. I kept the page open to show you guys. I think I closed it maybe. I'll just look up for that page again. Okay, let's see, where is it? No. Okay, I'll just take 1 minute to find it again. Okay, so right now I'm searching in my secondary screen for the updated documentation page, which I am unable to find. Okay, so no problem. I will just make it myself then. So check this out over here. So now just let's understand the normal concept first. So we have the pods. For example, if you want to talk to the SQL database and MySQL and storage account and so on and so forth, we have this pod identity service, which basically let you use the Active Directory, Azure AD, for all the communication. Not for the communication, for the authorization and authentication, right? And communication will happen anyways directly right over here like this. So what these pods do, they use the pod identity service to get the tokens from the Active Directory, and the Active Directory will give the, let's say, identity token and will return the token, and the pod will use the token to get the data from the to the database, MySQL or storage account and so on and so forth, as such. So we don't have to create the dedicated connection between them. Like what we did right now is we literally took the connection string and we use that connection string to connect between both of them, right? There is another token based concept. By using the you can say the tokens, you can do that identity token and even the access tokens over there. Now what we have done is more in this field. uh, we hard coded our secrets. We wanted to keep the secrets in the key vault. Now key vault is another service of Azure which is built on HSM concept, hardware security module. So if I just make it for you, so there are hardware devices called as HSM devices, hardware security modules. So Microsoft has purchased all of these hardware uh, HSMs, and they have kept them in their data centers like this. And the service which is built on top of this HSM is called as Key Vault service. So imagine this Key Vault which we have created here, and then also they have created two different type of pricing there, like the software defined key vault and the hardware backed key vault. So in the premium one, there is a key encryption key which goes over here like this. In the software protected, it's not hardware protected. It's just software protected. So this is the hardware protected. Now, so the key, the secrets, the connection strings, password, encryption, anything which everything and anything, nothing should be there in the configuration file. All the things should be in the key vault over here. And then that key vault is something from where you can say the connection strings and the passwords, right? Password, connection string, username, uh, right? Any other information which you think of, right? All those things comes there. There is a question: is it like RSA token? Mm, no, not really. Okay, I'll just show it to you. So I think I should have shown that first, but this is HSM. It's a it's literally a hardware device as such. So like that. So these devices we have in our offices or we have in our data centers. So when the customer they go to the cloud, they also want the same thing, right? Because where will they keep their encryption key? So we didn't even talk about the MySQL encryption. Like there can be encryption at rest. So where will you keep the key? Not in a laptop, right? So that key is supposed to be kept in the key vault. But how will that key vault like that has to be somewhere, right? So what they have done, they have created they have bought, imagine these hardware devices, HSM devices over here. which we also use on-prem. And then they have created two type of pricing on top of it. There is a standard pricing which doesn't use it. It's a software protection, and there is a premium pricing which uses that. This is the premium one. So there is one key over here, and the key which is encrypting that key, the key encryption key. Okay, so think it through. This is a data encryption key over here. Data encryption key. Then one key will encrypt that key like that. That second key is the key encryption key. So KEK like this. So it's more secure in this manner, like backed by hardware or backed by software. So hardware is more secure. So the next step for us is to use the Azure Key Vault for that purpose. Now, if if I just take it back. Okay, so if I just hold it from here and move it. So now configure the key vault, put the keys inside the key vault. The key vault needs access control. Key vault will also involve Active Directory for getting the key from the key vault also. Then the rest of the process still flows. The pods will request for the tokens, right? The pod identity service is there, which is the way by which the Active Directory is exposed for Kubernetes based pods. So you can say the pod identity uses the you can say assigned ID to obtain the token on the behalf of the pod over there. So that's a token got received. Now the pod uses the token to get the connection string from the uh, from the key vault. So it gets the connection string back, step number 6 over here. And then with the step number 7, it makes the connection with the database, MySQL DB over there, which will be connected to this network by a private link and private endpoint. And after that, this is going to happen, right? On top of it. So this is the absolute way of doing it. But you see this service called as pod identity service. This is upgraded now. This diagram, that documentation page was not really updated. The new name of this service is over here. I uh, I actually know that, so I kept the page open. But the new name of that service was workload endpoint service, something like that. It was. I will see if when I'll answer your questions, I'll see if I can find the new name of the service. But just FYI, it got updated and there is another updated version. The problem with this service was that it was having some less support for third-party identity providers. What happened if this is not what you're using? You're using something else, Ping, or you are using some another third-party one, right? With maybe Microsoft partner, maybe something else. Then it was having limited support for that, so they have taken care of it. Now this is renamed as workload identity service, something like that. And but the flow remains same. It is even more can say upgraded and way better and so on and so forth, right? So let me okay. So let me just take your questions now. This is more or less what I had for the session as such. And let me just take your questions. And let me just take it back here. Okay, I'll keep this page open. Now, if I just scroll to the top and I will just take your questions from the starting. Right, can we have a single pod in AKS? We should have used ACI. This one is not the suitable one. I'll give you the answer over here. So you have to look up in this manner. You have to say Azure Compute Options, and you have to go to the Architecture Center of Microsoft like that. And on this page, this is the flow diagram to be used uh, when deciding between these services. So which service should be used when? This link is in the chat. Use this flow diagram, and this is what you are looking for, this one. When we don't want full-fledged orchestration, maybe like that. Otherwise, we can run it here, but it will be expensive, right? How will you justify running just one pod there? It's supposed to be, the cost will come down by increasing the density of the application. So that density will not be there, right? Okay, now kubeproxy is a networking concept. Does Does the core DNS comes in default namespaces? Core DNS comes in default namespaces, yes. We also didn't do any, I didn't even made any namespace. So, and let me just open core DNS. Luckily, I have it over here with me, somewhere over here. So we have, this is, we have like, this is that core DNS service over here. Okay, we were not going in that today. So how does the master discovers the pod IP? That's what we were thinking in this here. I think we, I think that question was asked before it or something. See, like this. The endpoint object which we have, this is available to the DNS service load balancers and the queue proxy over there. To everybody, it is available over there. So uh, right, this is how it basically finds it. Remember this, that when we make the service, one endpoint controller will kick in, endpoint controller will make the endpoint object. This is how it will look like. It will make it available to all the load balancer, DNS services, and queue proxies throughout the cluster over there. So it will provide it. This endpoint object will be available to all of them. And mm, like this. Okay, so let me take another question. What is a daemon set? Daemon, how does it work? Daemon set, okay. Daemon set is basically, let me share one documentation with as well over here. So let me take this and put it there. Official documentation as such. So basically, this is what it does. Like the use cases are here. Like let me see if like this. So a node are added to get the cluster, pods are added to them, the nodes are removed from the cluster. It's sorry, I think this is something, let me find any proper, this is the page which you can go through and read the page, and I'll see if I can share another easier link than that or not. Okay, now. Okay, so I think somebody already found the mistake I was making, that both the ACR and AKS are in different RGs. Yeah, uh, copy paste error. Okay, so please go ahead, ask your questions. Okay, so I'll just walk you through the let's say then the post session links little more. In the meantime, you ask your questions. So I will open those two links which I gave you earlier. Uh, mm, Let me just find those two links. So now, if I just find the two links. Okay, so what I have just shown you, that exact deployment, right? That exact deployment is on the link which looks like this, right over here. Deploy WordPress app on AKS with the flexible server. Prerequisite is there: install CLI, install PowerShell, create the resource groups, create the AKS cluster, connect to the cluster, and so on and so forth. Make the flexible server and do all the various steps over there. Uh, over there. So this link is already in the chat, right? Go through it, and this can be your go-to session after this can be done after the session today. Okay.
You want the mics unmuted to ask the questions?
You can also do that.
Yeah.
Right,
We
guys,
can ask the questions.
you can unmute your mics and ask the questions as well. Okay, so in the meantime, you can also follow us if yeah, Anil, go ahead. Anil, I can see your mic moving, but I don't hear you. Okay, so not yet. Is it something?
Can you hear us, Anil? We are not able to hear you.
Anil, use the chat. You can put the connection, the message in the chat. Others, ask anything as such. Uh, Anything you want to share with us, and so on and so forth. The session is slightly shorter, so we can use this time for discussions. Can we set the boundaries? Yeah, yes, very good. Yeah, I'll show you. Just 1 second. Boundaries. So now to do this, check this out. So I'll give you this link in the chat. If you want to, from here it will start from this one, and then I'll just show you the boundary part which you asked for. It's just the resource utilization which you want to specify. So let me just go to the GitHub page where they have hosted that, and let me open the YAML file for in that example, and let's see if they have done it somewhere here or not. And yeah, something like this. See the boundaries for the pods like that. The limit, the upper limit, and the requested 250. You can say uh, so see milli CPUs over there like this. And the link is there in the chat. If you do that, that particular tutorial is doing this part. Please share some more information about the MySQL flexible VMs. Flexible VMs, you mean flexible cluster, right? The PaaS solution. Right. Okay. So more information. Okay. Then I think I should take you to the documentation page, and we'll find more information over there. Then okay. So check this out. Now it's a PaaS solution, so we'll not use the word VM. It will go in the PaaS field. I'll give the correct landing page over there where we are getting all the things. So for example, I'll see if I can find something interesting from the concept part over here. So all the concepts are here. Anything which we should know or needs to know will be in this section over here, in these 7-8 options here. So for example, concepts for server management will be here. Like this is what we were discussing about the server parameters, uh, those 300 parameters which are there. The networking concepts are here, like the public access, private access, and the networking concept. So uh, uh, this is where this is uh, right over here. So you can go and see a little more into this networking part. Then the server maintenance part is here. This is what I was showing you, the scheduled maintenance part. And the high availability is what I was also showing you before, where we were talking about that single one zone HA and the multi region part. Monitoring section is something which we didn't go and looked into much, but we were seeing how can we do the diagnostics over there. But it's just by setting it up, it's not enough. You have to run the queries. You have to make the queries. So that query details will come on this page further. Like what type of queries are there? See, like the list the top 5 longest running queries on a particular server. So this page is useful. I'll give this page as well over there, where we are running specific custos queries, like the queries which took more than 10 seconds on a particular server, filter them. Then the slow query distribution on a particular server, this one. And replication is what I was telling you about, this read replica. Let's see if we have a nice diagram here or not. Okay, no diagram, but this is what that 10 replicas was. And backup and restore are the same things, which we were thinking that, okay, it will take one backup every 7 days. Sorry, one backup every day by default, and we'll keep it for 7 days. But maximum retention is 35 days over here. And frequency should be written somewhere in this box. So the first snapshot is taken immediately, are taken once. Yeah, okay. Snapshot backups are taken once every day. The transactional log backups happen every 5 minutes. So these are transactions which we are doing with it, and the snapshot is once in a day, like the full snapshot of the entire database. And then it keeps it for we can set it for 35 days. So I'll just correct myself. Uh, it does take it once a day, but that's the full snapshot. Transactional backup is every 5 minutes. Okay, and ZRS is the slow one, but it will be extremely lot of nines are there as such. And this is actually the storage part of it. This is not the database HA. Don't get confused. This is the storage, the backups HA, because the backup is going in a storage account, so and so forth. So go through this concept page here. It will cover all the things which we should know about the MySQL. And here the tutorials are there after that. AKS versus serverless solution for WordPress. When to use what? Serverless solution for WordPress. Okay. There is a problem as such. Check out my problem. The problem will be is this. Now let's talk about PaaS versus serverless, right? Let's talk about something over there. Now, and I'll take one. Maybe I'll take one example while I'm explaining it. So I'm just looking for one e-commerce example. Just no, 1 second. I'm just looking for one picture image diagram in my secondary screen. And I just want to do a thought process on like, can we even go serverless or not in in any application? Like the application should support it. I'm not sure if WordPress supports it or not. I'll explain it what I want you to remember. Okay, check this out. It's a very simple solution here. I'll just put some numbers there. The image belongs to the creator. It's not my image. I just Googled for it. Now, this is where the mobile application is, like that. And the people are placing the orders right now, right? Like this. So the post step number one, the order, they are trying to place the order right now. So one, then there is one order service, seems to be this one. What this order service does, this is one of the microservice. So this microservice is what can be there inside Kubernetes, right? So I will just write it over there that this is inside Kubernetes. Hypothetically, we are putting it there right now. Uh, this is one of the consumer, and this is inside Kubernetes, one of the service. Like today we made the WordPress, this can be another one. Now, then the event got written in another event log, immutable event log. Don't worry about it. But then there are other services. See, this service over here, this service over here, and this service over here. These services are then what they are doing, 4, 5, 6. These are reading those immutable event log, and then they are doing three things parallelly. Like not parallelly, meaning they are doing their own thing. That's what I want to say. And then the output which comes, it goes back into the event log over there. So 7, 8, 9, like that. And then somebody picks it up, another service picks it up, and then does the order validation. And then once the order has been, sorry, that was the last one. This is the order created. Yeah, correct. Order created, order validation. This is order validation. So like the validation is going on. Validation of the order is going on. It's available. The flight is available. The t-shirt is available, and so on and so forth. So finally validated. Validation is going on. This is validated over here, like done. So now order got placed, and so on and so forth. So in the response, 8, 9, 10, the finally something happened. The person got the message or something response that the order was placed. Okay, now what I want us to remember is there are short running jobs and there are long running jobs as such. So like long running jobs such as maybe the entire website itself, right? This is suitable for the platform as a service solution, like what we have. You can have this in past solutions. You can have this in any other, maybe a container where that runs inside Kubernetes as such, right? The website, the way we have done it over there. But now let's imagine one small use case here. Let's say when the customer places the order, then when the customer places the order, then the PDF needs to be created, the invoice PDF, right? The invoice PDF needs to be created, and then that invoice PDF needs to be emailed to the customer, and also the download maybe needs to be emailed, or download link needs to be there. So now this job which can do that can be a short running job. Why? Because if you think it through from e-commerce website, around 70-80% people, 60%, right? 60 to 70% people are not buying anything. They are just browsing. So only 30%, 40 to 30% are buying it. And then also they don't buy, like people don't buy non-stop, right? Maybe in very big use cases, maybe there is non-stop orders, but you practically think it through, right? Anything. So short running job basically means something which I can trigger, something which will execute, and the output will come over there, and the output will be invoice, and that output can go in a storage account over here. So this component over here, this piece of code, we don't have to run this non-stop. What we can do is this can be a serverless component. Like we can have Azure functions as such, and those Azure functions can pick up the when the order was placed in the order database. Order database can be MySQL. So when the row was added there, then this got triggered like this, and then when it got triggered, it created the PDF as such, and this PDF URI was the one which was you can say which was maybe available was made available to that user for download purpose, or maybe it was shared over the email also, like this. So the short running jobs uh, can be serverless. So so think about that in any application. What can be the thing which we can trigger, which we can call, and that will do that thing, and will terminate or deprovision. So those components can be serverless. So in I need to check in WordPress what components can be serverless. I don't have information about that serverless part over there. Pretty interesting question, but this is the thought process behind it. How to handle local volumes? I think you want to mount it, right? Mount the local volumes, correct? So I'll give you how to mount it. Handle use needs to mount it first. Persistent volumes. So we have a lot of options for that. We can mount. If I can just show it to you somewhere here, we can mount. I have done sessions of this before, persistent volume and the volumes and so on and so forth. You can look up for the previous sessions also, but the managed disk and the Azure files, we can have the dynamic ones, the static ones. The file can be now the file can be of three types actually: the hot, cool, and the transactional. Optimized one. Three options are there. Four are there. SSD is also there. So yeah, so you can see these options are there. Uh, Maybe all the options may not be written here because one of them recently came out. but this is the correct page. If you go to this page, and the instructions will be somewhere in the bottom of the page. So this is how it works. Like there is a persistent volume, which is like a storage account. Sorry, this is like a file share here. That's your pod, and we do the PVC, the persistent volume claim, and then it gets mounted, and then you start working with it. So this link is going in the chat. There is another big question in the chat saying, awesome, since we have already data in the managed DB, we can host our WordPress. Okay, problem with ACI is not auto scaling. So you cannot use ACI. That's out of the picture. You have to use AKS for that auto scaling solution. Otherwise, if you otherwise go for app services, uh, Azure Web Apps that can also host the front end. Otherwise, you have to go for if you're looking for AKS, you can go for it. ACI cannot be used there. Uh, use this page. That auto scaling functionality is something which orchestrators can provide. Right? Okay. So
Any other questions?
okay, then you can also find me on LinkedIn, right? You can, if you have any follow-up question, feel free to put it there. And I will be delivering another session next week. So please join me and others also for these sessions. And do let us know as well in which sessions do you want us to do in the next iteration. So another iteration of Reactor will start. So if you have any choices, you want to go in some, we generally do cutting edge. We cover the cutting edge technologies as well. But in case you have anything specific in mind, which is very specific, uh, then do help us with those ideas and topics and things, right? Okay.
Let's call for a wrap up then.
Yes. So if you find me on LinkedIn, guys, please join the Reactor page. Parth, if you can just paste that, the links which you have pasted earlier, where they can find the recordings and the Reactor page, then they can
Sure.
just bookmark it. Okay, Anil is making a statement, it seems. The stateful databases will be stateful. Yeah. So these links are there. LinkedIn group is there. The upcoming events are the second one. Find me next week. There are two events, very interesting events are there. One is on ML ops, and the other one is on another machine learning topic is there. And the recordings are available on the third one. Please find us. Please find the previous sessions there.
Thank you, Shivam, for the session. And thank you all for joining us today. Please do share your feedback about today's session. Also, feel free to use to learn the Learn module link in the chat section, which is given by Shivam. This will access you to the additional resources to take your learning further. Also, please visit our Microsoft Reactor Bangalore meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of your day.
Thanks everyone. Thank you, Parth. Thank you, Vivek. Have a nice day.